Hello students, we'll continue again with unit number 2 and topic number 2, which is detailed construction planning and role of client and contractor. Detailed construction planning. A construction management plan is a document that encompasses or entails detailed information on mechanisms, tools, resources, and the knowledge transfer which is necessary to deliver complex construction projects. So the plan enables project managers to determine project feasibility and develop resource schedules that align with the goals and objectives. It further facilitates efficient project resource planning and management. With an organized plan and schedule, managers can be held accountable and ensure that the workforce is committed towards timely and quality accomplishment of the construction work. Next, construction management plan. The first point under construction management plan is we have to define the project scope. The project scope is inclusive of the project goals and objectives, deliverables, features, financial tasks, and deadlines. Defining these variables builds the foundation of your construction management plan. Next point is resource capacity planning. Once the project scope is in place, the construction management plan should have a resource schedule ready. So building the right team to accomplish varied tasks is crucial to get a head start on the construction project. Managers must therefore assemble the right workforce and allocate the right task to them to avoid any potential bottlenecks in the future or problems in the future. So capacity planning before project execution also provides enough window to the manager to recruit the resources well in advance and eliminate delays. Third point, phase design and budgeting. The overall project plan must be divided into small phases or small projects. This will enable decision makers to track the progress at every stage conveniently. In addition, designing each phase facilitates accurate budgeting as the management practices and methods to be employed are explained explicitly. So phase designing and budgeting is vital to get an estimate of the total revenue that will be generated. It will also facilitate managers to assess the feasibility of the project. Next point is stating the interdependency. So, enunciating tasks and their interdependencies on other departments is a must in construction projects. That's because construction projects operate with cross-functional teams and coordination is required between every team for the project success. Thus, the plan created by the project manager helps them supervise the construction planning and ensure that projects are completed on time. These are the essentials of a construction project management plan. Of course, managers can configure the plan as per the projects and requirements. Next, steps involved in detailed construction planning. Number 1. Document the scope. A comprehensible scope outlines the construction project's goals and purpose in terms of its value and benefits. It is a compilation of both the stakeholders' and clients' expectations and inputs. After diligent analysis of every input, a scheduling plan for the construction is developed. In addition to this, a project scope explains each and every team member's roles and responsibilities in detail. It also includes the project's time frame, financials, methods, and techniques to be employed. Moreover, it consists of factors that may adversely affect the project's progress. Number 2, draw out a work breakdown structure WBS. A work breakdown structure WBS, as the name suggests, is a deliverable-oriented breakdown or bifurcation of projects into smaller tasks. Drawing out a WBS allows project managers to categorize the projects into manageable chunks. They can schedule and allocate the right tasks to the right resource at ease. One of the major benefits of designing a WBS is that it enhances task management efficiency and helps managers ensure uniform allocation of workload. A WBS is therefore necessary to help project managers track the project's progress at every stage. This will help them implement corrective measures in case of any discrepancies. 3. Feasibility study. A construction project depends on environmental, social, and financial factors. A shift in even one of these can impact the project's progress. Before beginning the execution, project managers must meticulously assess every factor. They should also analyze if the project is prone to environmental hazards or if the project will be profitable enough. This careful evaluation This careful evaluation constitutes the feasibility study. Before investing the resources, their time and the project costs, conducting the feasibility study is necessary to ensure the project's success. Number 4. Cost and time analysis. Major construction projects cost thousands of dollars to your firm every hour. So a slight delay in the timeline can eat into your organization's profitability. So managers can prevent these setbacks from happening by running an extensive cost and time analysis. This is only possible when they have centralized visibility of the project task and resources booked to complete them. With a unified view, project managers can calculate the resource and equipment costs, which will help them calculate approximate total revenue. Thus, cost and time analysis is crucial to ensure that projects are delivered within time and budget. Note that employee leaves, holidays, buffer time must be taken into consideration when analyzing the timeline. Number 5. Quality control and risk management. Stakeholders and clients have to be specific with the project quality they want. This quality is clarified in terms of material and the final output. The onus is on project managers to ensure that this quality is maintained throughout the project life cycle. More importantly, a risk management plan has to be in place when you are dealing with construction projects. This is because these projects are not only prone to time and cost overruns, but also pose safety risk. A construction management plan therefore must have a contingency plan and quality control audits. 6. Documentation of communication plan. When a project pivots on cross-functional departments, transparent communication and coordination are imperative to ensure smooth functioning. If one team faces a challenge, it can communicate and notify other departments who are dependent on them. This way, curative steps can be taken in time to avoid delays and further roadblocks. So these are the steps to be followed to document a systematic and well-organized construction management plan. The next topic is role of the client and contractor, and below it the subheading is client role before the construction. Number 1. Budget allocation and cash flow insurance. 2. Concept study and verification of intended outcome. 3. Bidding or tendering procedures, that is evaluation and award. 4. Selection of EPCC contractor or contract agreement signing. 5. Kick-off meeting, and 6. Approvals from authority if any. Client role during construction. So design review and approval in some cases. 2. Progress review meetings. 3. Frequent visit to project site. 4. Invoice verification and payment. 5. VTC or change order review and approval. 6. Major vendor finalization. 7. Punch listing and QHSE auditing. And number 8. Commissioning and taking over of project. Client role after construction. Number 1. Operation and maintenance of the project. Number 2. Complete payments released to vendors and EPCC, which includes retention. Number 3. Approvals from authority. And number 4. Ensure availability of warranty and spare parts. The next topic is role of contractor. Responsibility of a contractor in construction is the execution of the work activities that are required for the completion of the project. The roles and responsibilities of contractors manifest themselves in various aspects of the project, for instance, project planning, management, monitoring construction site safety, and legal issues. So the contractor also appoints subcontractors who have special expertise to execute certain parts of the project that cannot be constructed by the contractor. Subcontractors involved in construction processes based on services that they provide in the course of a construction project. A contractor is a person or an organization hired by the client to complete the project. In summary, the roles and responsibilities of contractors have many different levels since they carry out a broad range of tasks and manage numerous individuals. The roles and responsibilities of contractors may be slightly different from a project to another, but the general roles and responsibilities of contractor are nearly the same, which are presented below. That will continue in our next class. So give your name and enrollment ID in the chat box. That's all for this lecture. Thank you.
What often happens is, while constructing a road from this point to this point, you may have acquired land for this package, you may have acquired land for this package, you may have acquired land for this package, but there will be a package somewhere here and a package somewhere here where land acquisition is an issue. So that doesn't mean that you don't start the construction work. Very often we start the construction work, but hoping that while the construction reaches this point here and it reaches from here to this point, these pockets of unacquired land will also be acquired. So of course, coming back to our example, if the land acquisition is cleared, we can go ahead with tree cutting without any preceding activity. But as far as excavation is concerned, it's not possible, it's not proper to start excavation. You cannot start excavation unless you have completed activity A, which is tree cutting. As far as activities C, D, and E are concerned, that is general grading of the area, excavation for utility trenches, and compacting the subgrade, they can all be started only after a general excavation has been completed. So continuing further, activities F and G, which is installing sewer lines and installing electric poles, they depend on C and D. That is, they depend on grading general area for leveling and excavation for the utility trenches. Finally, the laying of pavement depends on E and F, that is, compaction of the subgrade and installation of the sewer lines. Installation of the sewer lines, because very often the sewer lines actually run below the pavement. So only once you install the sewer lines can you complete the laying of the pavement. Now, from this example, it is clear that there exists an interdependency among various works involved in a project, and they can be actually represented in a logical sequence. In this case, we represented it by means of a table where we listed the different activities and had a column where we listed the required preceding activities to have been completed before those activities are taken up. Now, in fact, one of our earlier discussions also, when we talked about the boundary wall, we had given 19 activities as part of the breakdown of that boundary wall construction and had left it to you to complete the or think about the interdependency the way we talked about just now. Having done this illustration on the work breakdown structure and the concept of interdependency, let's closely look at the fundamentals of network planning, because we would like to represent the different activities by way of a network. That is so much easier to represent, explain, and use when we are trying to monitor the project as the construction work goes on. So before we start application of networks to our construction scenario, let's try to first study a little bit about the network fundamentals. Let's define a few terms. Let's talk of an activity. This is an item of work that involves consumption of resources and time. Of course, time can also be looked upon as a resource and produces quantitative and measurable results. The activities take place between events and they have a well-defined start and a well-defined end. So if there's an activity called digging the trench or concreting a roof, there is a very well-defined start to that activity and a well-defined completion of that activity. Coming to that event, it indicates the start or completion of one or more activities. An event does not consume any time or resource. Of course, there are some dummy activities which we will see when we try to see the logical compulsions in drawing up networks and representing the interdependencies in the form of a network. We'll find that we need to have what is called a dummy activity, and these activities do not consume any resource or time and are used only to basically complete the logical interdependency among the different activities. And what is a network? It basically is a graphical representation of activities in terms of nodes and arrows to show logical interdependency between activities. The network helps us better understand the sequencing of activities, gives us various informations about the project, such as the time required for completion of a project, the activities that need to be monitored more closely than other activities, and the basis of plans for material procurement, manpower deployment, cash flow, and so on. And of course, we can also use this whole concept to determine the probabilities of completing the project within a certain time. Now, there are two types of networks. One is called the activity on arrow. Activity on arrow means that there is an activity A and there is this arrow between nodes I and node J. So this activity A is actually represented as Ij, where I represents the start of that activity and J represents the end of this activity, and A itself sits on the arrow connecting I and J. So these arrows are directional. So it's an I to J arrow and not J to I. It's not interchangeable. It's an activity Ij, which means it starts at I and ends at J. On the contrary, we can have an activities on node kind of a network where A and B are represented as nodes, and there is an arrow in between which shows the dependence. That is, B depends on A. You cannot start B unless you complete A. So if this concept of A and B being related the way they are shown here in the activities on node representation, then what we will do here is to put B here and put a node K here, which means that A is the activity Ij. When this activity is completed, B can start, and B is represented as Jk. So the node J is the start of activity B and is also the end of activity A. So these two representations are the same, except that in this case, the activities are on the node. A has to precede B. In this case, the activities are on the arrow, and I, J, K are the nodes. So the activities are, to repeat, I, J and J, K. Now continuing with this example, there is an activity, let's say digging a trench, I and J. It basically represents the start of the digging of the trench and completion of digging of the trench. Now going back to the previous example of 8 activities, let's try to see how we can represent this information of 8 activities in terms of an activities on arrow and an activities on node network. So if we look at this picture here, this is an activities on the node representation. We start this project here. This is activity A, B, C, D, E, F, G, H, and the project ends. And we can see that the information given in the previous picture, A can be started without any preceding activity, not counting land acquisition because that's not part of the 8 activities that we have listed. B can be started only after A has been completed. C, D, and E can be started if B has been completed. So here it's G can be started only if activity C and D have been completed. Similarly, F can also be started only after activity C has been completed and activity D has been completed. And H can be started if activity E has been completed and activity F has been completed. So this is how we have represented those 8 activities A, B, C, D, E, F, G, and H in a activities on node network. So now let's try to do the same exercise in the activities on arrow, and I leave it to you to make sure that the representation is correct. A is 1, 2, B is 2, 3, C is 3, 4, and so on and so forth. So I leave it to you to verify that A does not depend on anything, B depends on A, C, D, and E depend on B, F and G depend on C and D, and H depends on E and F. Now here you will find this activity here. This is precisely what is a dummy activity, basically to show that G depends on both C and D. The reasons for that will become clearer in some other examples that we do later on in this course. Now continuing with our discussion, let's try to see what are the basic rules to be followed when drawing networks. Usually there is an event included as a start of the project and an event called the end of the project. Each activity should be represented with only one arrow pointing towards the direction of the progress of the project. No two activities can have the same I and J. For example, both A and B cannot be represented as 1, 2. What has to be done is that we have to use a dummy activity and try to say that, well, activity A is 1, 2 and activity B is 1, 3. The node 1 represents the start of activity A and the start of activity B. The node 2 represents only the end of activity A, and the node 3 represents the end of activity B. Normally, it should be ensured that J is greater than I. Now, the following checks usually help in drawing a network. The first thing being, which activities must immediately precede a given activity. Then, which activities must immediately succeed a given activity. And finally, which activities can be done concurrently. So if we are able to keep track of these three issues, we will be able to draw a network. Now let us try to carry out this exercise using an illustrative example where what is given is a project with 4 activities A, B, C, and D, where A and B can be started independently. C depends on both A and B, and D depends only on B. Now let's try to construct the network. We start the project with A, which is 1, 3, B, which is 1, 2. They can be both started immediately, and node 1 represents the start of both A and B. Node 3 represents the end of A, whereas node 2 represents the end of B. So C is the activity 3, 4, and it can start only after A and B have both been completed. But D can be started as soon as B has been completed and is the activity 2, 4. A and B are of course activities 1, 3 and 1, 2 as is shown here. So now we have converted this tabular information into a network diagram like this. Let's try to do another example where information about the activities is given as follows. Activities A through E, 5 activities. A and B start independently. C depends on A and B. D depends only on A, and E depends only on B. Now for this particular situation, A is let's say 1, 2 and B is 1, 3. We have a C which is 4, 5 created with the help of 2 dummy activities 2, 4 and 3, 4. Nodes 2 and 3 represents the completion of activities A and B, and once both these activities have been completed, we are in a position to start activity C at node 4, and 4, 5 is the activity C with 5 showing the completion of activity C. Activity D, which depends only on A, is represented as 2, 5, and similarly activity 3, 5 is the E. Please remember that this is not the only way of representing this information in the table. There can be another network which shows this, but one of the points that we must keep in mind when we drawing networks is that the number of nodes should be kept to a minimum, the number of dummy activities that are used, that should be kept to a minimum, and so on. And that comes through experience. As we draw more networks, as we become more adept at drawing the networks, that comes naturally. And with this, we come to a close for the discussion for today, where we have basically tried to introduce the concepts of networks and how to translate activities which are given in a tabular form along with their logical preceding activities, and trying to convert that tabular representation into a network situation. These books will probably help you understand the subject matter better, and I look forward to seeing you once again. Thank you.